Hello again, everybody. This is Joseph continuing with schematics, interpretations of schematics, and how to diagnose, how to troubleshoot. I thank the viewers who told me that they're using the videos for exams and ASC exams. I thank them for that. It really humbles me when they compliment and comment about my videos. Now, if you're going to take the ASC certification for automotive, the electronic part of it, there's about 9 exams given to be a master technician. You have to know symbols, you have to know diagnosis, you have to know the basics of electronics. Now, first, you always have to know are the symbols, what they represent in any schematic. You have to know the relationship between current and resistance, and also voltage. If current goes up, that means the resistance went down. If the resistance went up, obviously less current in the circuit. You have to know that relationship. The voltage is equal to, and this is Ohm's law, voltage is equal to resistance times current. The unit of measurement for current is in amps or milliamps or microamps. Remember that. Resistance is in ohms, kiloohms, mega ohms. Voltage can be in volts or millivolts. You see the direct relationship. As resistance goes up, voltage goes up. As current goes up, voltage goes up. So if the current goes up and the resistance stays the same value, the voltage will go up. They are directly proportional. You have to know the relationship. Now, this is a meter that I have. You have to know how to use a meter, obviously. You have to know how to use it as a current meter. You have to know how to use it as a voltmeter for ASC. These questions will be asked. Guaranteed. So, voltmeter is always connected in parallel across the component. In other words, if I want to measure this bulb, this represents a bulb, a light. I put this across, and I put the other side, the negative, across the other side. Now, we always usually leave one probe at ground. This is ground. Take a look at the schematic. This is ground. So, in other words, we're doing with reference to ground, with relationship to ground. We always leave the negative at one point at ground. It's more convenient that way. And we say with respect to this point, which is ground, how much do we measure across here? How much do we measure across this bulb? How much do we measure over here? So remember that. With respect to ground, we measure voltage. Now, the current meter is a little different in series, meaning you have to break the circuit. Now let's take a glimpse at the schematic. Pretty difficult schematic, isn't it? Well, you can simplify it for yourself by what I was stressing. Always focus on main symbols, main components, the key components I call it. As you see, I have arrows showing them. The relay is a key component. This is a key component, the ignition switch. The combination meter for Toyotas. This rheostat module is a key component. Right? So you focus on those things. And I made so many videos how to interpret. Remember, when you look at a schematic, you have to go up sometimes, back, this way, that way, this way. You do not always start from the battery, like I pointed out so many times. If I have a key component that I'm working with, this module, then if I'm supposed to have 12 volts, then I backtrack and see where it comes from. That means I have to go back, not necessarily always going forward in a schematic. Now, let's start with the key. Those of you taking the ASE, electronic part of it, or for certification, like I said, remember the symbols, the components. We'll start off with the basics. The battery, which is 12.6 volts. Now, with temperature, obviously the battery voltage changes. the cranking amps, and you have to know cold cranking amps. Cold cranking amps is at 0. Cranking amps is at 32 degrees. Now, you have to know those things. The battery is at 12.6, but maybe at 70 degrees, 80 degrees. But as the temperature goes down, obviously the output will drop, obviously. Like in winter, obviously. Now, we know these are cells. Okay? 1 cell, 2 cell. So, if you have 12.6 volts in a battery, each cell is 2.1 volts. That means there are 6 cells in it. I noted this one to make it this FL, fusible link, as F6. If I want to know how much current is flowing, the total current, not the individual current, where do I put this meter? Number 1. Number 2, if they ask you in an exam, where do you put it on? Let's look at the meter. We know volts. This goes up to 1,000 volts. This signifies DC, the straight line. This signifies, the black part of it, ohms, omega. If I want to measure amps, this signifies amps, but for AC, look at the sine wave. If I want to measure amps DC, up to 10 amps is this one. Anything from here to here for DC. For AC, anything from 10 amps to 200, and this is micro. Volts AC is from here, 200, and look at the M. Look at the M. That means 200 millivolts, as I stressed before, which is equal to 0.2 volts. 0.2 volts, 2 volts, 20, 200, 750. Usually we use it for DC, automotive. Okay, which is the proper jack? These two are for amps, for current. So if they ask you which jack is for 10 amps, it will be this one. If they ask you which jack is for 200 milliamps, it will be this one, and this one common. If they ask you the volts and the ohms, this one on the test, on the exam. So, keeping that in mind, I want to measure the total current going through this. Where would I put it? 1 or 2 ways to put it. You can put it to positive. You have to break the circuit. You could take this fusible link out, and you could put the meter on amps and measure it in here. Where would the positive of the meter go? Right here. The positive goes here, the negative will go here. Now usually when we measure a current meter in series, we put it to the negative. Where is the negative? Right here, the ground. So we take the negative of the meter here, and the other positive going to the other place, wherever would be connected to the other cable. Take the cable off, the negative, right? The cable goes to, negative goes to here, and a positive cable goes here. We take off, we go back, we will go to the terminal, the negative terminal, and the positive will go to the cable. That will give us a total current. Now, battery has polarity. If they ask you in an exam what other component has polarity, think about it. The answer is a capacitor, electrolytic capacitor. Where are they found in? Power supplies. Among other things, obviously, filter circuits all over, but electrolytic capacitors. Other ones do not have polarity. Electrolytic has a positive and a negative. That's the other component that has polarity. Now, if they ask you on an exam, where are, as I said, you have to know symbols. Where are fusible links? Okay? Let's look for the fusible links. Can you come over here? Is this a fusible link? No. Look at the symbol. Is this a fusible link? No. This is a fusible link. How do you tell? It's thicker and it's more waves. This is a fusible link. What's the amps if they ask you? The rating? 40 amps. Right? What are the pins? that this is associated with. Pin 1, pin 2. Ask you to find more fusible links. Can you find another one? Well, let's look over here. This one right here. Again, how can we tell? This is thicker, wavier. Where's it located? Fusible link block. They even tell you this is a fusible link. Sometimes they will not. But you have to know the symbols. Again, fusible link over here, main one. This is the main one. See? Now you can see the waviness of it. Look at the difference between that and the regular fuse. So we have 3. If they ask you, where do you have fuses and the ratings? We have a fuse right here, F3. We have another fuse over here, 7.5 amps. What is this rated at? 10 amps. Question. Technician A says, we don't have any fuses. This is supposed to be 10 amps. We don't have a 10 amp fuse. Technician A says, put in a higher rating fuse. Technician B says, put a lower rated fuse. Who's wrong? Who's wrong? Who's right? Technician A or Technician B? None of them are right. If I have 10 amps and I have a 15 amp, guess what? It's not going to protect the circuit, because more amps will be allowed to flow in the circuit. That's the wrong answer. Do I put less? Well, if I have 10 amps and I put 7 amps fuse, when the circuit does draw 7 amps, it'll blow it every time. What's the answer? Put a circuit breaker if you have it. Right? Put a circuit breaker. Now, what do? Technician A says F3 is blown. Technician A says there must be a short. Technician B says there must be an open. Who's right? Technician A is correct. There must be a short. A short blows fuses. Now, what's the other alternative? Before you keep on putting fuses in and blowing them, take an ohm meter. Measure from here to ground. If I measure 1 ohm less than that, I have a short. Why should I keep on putting in fuses? Correct? Let me take out and diagnose where the short is. If I have a short, if this is connected to ground, this point right here is connected to ground, I'm going to blow this. And I'm going to blow the main one. You can bet on that. The main fuse is going to blow. So, the best thing is, if I have a blown fusible link, go from here to ground. Measure where the short is, and a short will blow a fuse, not an open. If I want to measure the voltage across here, this battery, how do I put the meter across it in parallel? A voltmeter always goes across. Positive will go here. Negative will go here. This is the positive. Positive will go here. The black one will go here. Correct? Now, ignition switch. Where in this schematic do you find an ignition switch? Answer is not this, not this, this one. In what position does ignition switch have to be for current to flow through F3? And they'll ask this on the test, on the ASE test, or any exam. The position for this to allow current to flow or connect to the circuit is ignition 1. So from pin 2 to pin 4, or terminal 2, terminal 4. As you see over here, there is no number. That's because there is no connection to anything. You don't see any wiring. The wiring is connected here. So this will be closed, and then you will have current flowing from the battery to this. Question. In what position does the switch have to be to crank the engine? Technician A says in accessories. Technician B says in ignition or start. Who's right? Technician B. Has to be in ignition. In accessories, all you have are the lights working, the fans working, and things like that. It does not crank the engine. You have to crank the starter. Sometimes instead of ignition, you'll have start, it'll say. or run or start. This has to be closed. The switch has to be closed. Question, where else do you find a switch? A normally open switch in the schematic. Technician A says, this is a switch. Technician B says, this is a switch. Who's right? Technician B is right. This is a switch. Is this normally open or normally closed? This is normally open. In the rest position, the default, I call it the default, it is open. If it's open, current cannot flow. If it's closed, right here, from here to here, current can flow. Okay? Now, where in this diagram do we find a relay circuit? Let's look. Is this a relay? No. Is this a relay? No. Where's the symbol? Right here. Technician A says we need the control circuit to be activated first. Technician B says we need the controlled circuit or the contact to be activated first. Who's right? The one that said the coil, this circuit, is correct. Current has to flow through this coil to magnetize it. It creates a magnetic field. The contact is then pulled in. Just like we said before, normally open, switch, this is part of the relay. This will close, you'll have contact from 5 to 3. How is this activated? From somewhere, or maybe a module or computer, giving this a ground. What are the 4 pins related to this relay? And they'll ask this on the exam. Pin 1 is the control circuit, and pin 2. The controlled circuit is 5 and 3. So current will flow through here, magnetize it, pull this in. Now current can flow through this. Okay? Now, question. This bulb over here, or any of these bulbs, how many filaments are in these bulbs? Question is, or the answer is, 1 filament. 1 filament. There are bulbs that have 2 filaments. That's not the case here. This is 1 filament, 1 filament, 1 filament. Now, other question. How much should we measure here? 12 volts. How much should we measure the other side of fusible link? 12 volts. How do I know that? Because there's no voltage drop. We didn't lose anything. The hard part about schematics, automotive, they don't give you the voltages or signals. You have to analyze it and figure it out. When I used to work with TVs, all the voltages were there to tell me. This is very different and very complicated. That's why I take the time to try to analyze and try to highlight and try to mention the voltages. I don't think you'll see it on any YouTube video. I might be mistaken. Leave that in a comment. 12 volts here. 12 volts to the top of the relay. 12 volts here. How much should I get over here? 12 volts. Why? I'm not losing anything in the voltage drop. Right? Now, I want to find the bulb that's related to the glove box compartment. Where is that bulb? Technician A says it's this bulb. Technician B says it's this one. Technician B is correct. It's this one. With pins 1 and pins 2. Now, the hard part. The very hard part. Now, Technician A says, we measure instead of 12 volts here, this is the fuse, measure 0 volts. 12 volts here, 0 volts with this probe at the other side of the fuse. Technician A says, fuse is good. Technician B says, no, fuse is blown. Who's right? Answer is Technician B is correct. The fuse is blown. Now, measure 0 volts here again. Technician A says the problem might be only the fuse. Only this can be the problem. Technician B says only this can be the problem, the defective component. Who's right? Who's wrong? They're both wrong. I tricked you. Joseph tricked you. Let's look at the schematic. We backtrack. There's 0 volts here. This is blown. Yes, it can definitely give you a 0 volts. But I will not get 12 volts over here. This is 0 volts here. And I come back over here. 0 volts, 0 volts, 0 volts. Can these be the problem? No, because I lost my 12 volts. So if I measure 0 volts over here, it cannot be that this is only the problem. And it cannot be that this is only the problem, because it depends how much I measure at the other side of the relay. If I measure 12 volts here and I measure 0 volts over here, yes, that means this is not closed. Or this is blown, yes. But I measure 0 volts, 0 volts, 0 volts. What could be the problem? Remember, we back probe. Can this be the problem? Well, let's go and measure. 0 volts here, 0 volts here, 12 volts here. Aha, this is open. I have 12 volts here. I have 0 volts here. If I measure 12 volts here, 12 volts here, right? And I come over here, 0 volts. Where did I lose it? Between this connection right here. Maybe the connector is broken. Maybe it's open. Okay? That's how you go about it. Again, 12 volts here, 12 volts here. That's good. That means I have it. Now, the tough part. The very difficult part. And for this, you really have to focus. How does the current flow in the circuit? This is the toughest. This is one of the toughest circuits I've seen with Lexus and Toyotas. And this is a training video for ASE. Current has to flow, we know, through all the bulbs. We see this over here. We see main key components. How does the current flow through all these bulbs? Let's say I have a bulb over here, right? I'd say these bulbs are out. Then I